Folks, see you speaking again. Today we're coming that close to start a new funny project. I want to present it to you first. Here it is. So last time we were talking about counters, and by placing here two counters, either BCD or binary, you are able to transfer that information on several kinds of displays. Like here we still have three displays. This one, 0.56 inches and 2.3 inches, and you have the same information on all these displays as long as it's digital, or BCD. Now, what is the purpose of these modules and adapters? Because the purpose for today is to describe that particular module we're going to build. And what is the purpose to build such a thing? Is this useful for anything or not? So before I'm answering straightforward that question, let's remember that what's the purpose in general for adapters and modules on a breadboard is to extend the capability of that breadboard, because you can take it in two ways. Either you want to put or to place more components on a limited space of a breadboard, or you may want to connect bigger components which are not fitting anyway on this breadboard, like a big display like this one. Okay? And both advantages can be taken if you know how to build adapters and modules. So let's find out what is going to be the advantage to build such a module. If you take a look, there are only two digits here. Again, they can be digits if you display decimal information, or they can be fully hexadecimal figures if you display 0 to 15. So from the 10 to 15 you have letters A, B, C, D, E, F. If you take a look at these two figures here, they take the same footprint or pretty similar to this one and that one, because this is a dumb display, 7 segment 0.3 inches size, exactly like this one here, which is one of ours. And if you take a look, the size on the breadboard is pretty similar to this if you consider this one together with the wires associated to its use. So why then to build a project like this when you can have them like that? There are several reasons you may decide to do it. Not only because it's looking much nicer arranged like the breadboard friendly ones. It may be a good reason, but it's not enough. Another technical reason is that this is an intelligent display. So if you just take a look right here where is a little square, in that square inside the package, you have the decoder. So the decoder is embedded in the same package with the display itself. So actually, you won't save any space for the display, because the space taken by this one is pretty similar to the space taken by two displays placed horizontally like this. However, you save a lot of space, because in order to use these ones or these ones, you need here and here one decoder for each. And if you use our new project today, you won't be in the situation to use these decoders, because you don't need to use them anymore. So this is the space you actually save for the two decoders. Another way to have the same result is when you use a bigger display like this one here. When you use a bigger display, you're going to make an adapter like the one I presented some time ago. I'm going to put a link in the video description. And by using that adapter, you can transfer all that electronics out of the breadboard. And here it is. You have the two displays exactly like this, and the decoders, which are not embedded like in the small ones. They are not embedded inside the digits. They are external. But because the board is external to our breadboard, you can just use the flat cable to transfer that information. So you can have the two decoders and the associated limiting resistors for the display, all external. Okay? So this is equivalent actually in function to that one. When you may have an advantage of using this one, anytime you want to make a project, a miniaturized project, you don't need big displays, you may have a good result with small ones. And it's another story if you have them like on another project I'm showing you here. I presented it a long time ago, and I'm going to put the link also in the video description. And this one was for the purpose of decoding the electronic codes associated to the keys on a keyboard. So if you take a look on the display, anytime you press a key on your keyboard, it's gonna give you another code, because each of the keys are different. So here, as you can see, the decimal points may even have a use, okay? But you may not always need the decimal points. For our module, I'm going to show you a bit later that you won't need to use the decimal points, but in case you need them, when you build such a project, it's much easier, because this is not on a breadboard. So when you don't have a breadboard, you just have a prototyping board, you can solder in the back whatever you want. So nobody else will see what happens behind, you know. But when you have a breadboard and you have to place a module on it, the situation is not exactly the same, okay? So I'm gonna leave this one aside, and I'm gonna talk about that little project now. So let me just stop the power for a second to remove the project and to show you what does it contain. The project is going to contain actually 4 steps. The first step is going to be to prepare the parts to be used. So then I have a list of materials, and you're going to find all these documents on the Google Drive. And here they are. I'm presenting to you the parts required. The first you need, I put all of them here in a little box. The first of them you need is a little prototyping board. It's a particular one from here to here, 3 times 10 centimeter. But the thing is not this, the thing is about the number of holes. It has to have 10 holes by 24. This is the typical board you're going to have. So this is the first item here on the list. 3 times 10 centimeter or 10 times 24 holes prototyping board. Very easy to find and cheap. This is one thing, okay? And we're going to obviously cut it and adjust it to fit exactly the size we need. Now, another part you need, actually 2 of them, I'm gonna explain you the reasons. You don't want to solder directly these kind of intelligent digits on the prototyping board. Because of this, you are going to need to buy or to order 2 little sockets, 14 pin each. It's exactly like the sockets you use for any integrated circuit, the 14 pin one you need, okay? So this is going to be the second position here on the list, so you need 2 of them. And then you need the digits themselves. As you can see, the digits themselves, these are typical ones, TIL311. TIL311, exactly the ones you need to place on the sockets. Next thing you need, you're going to need 2 rectifiers, and I'm going to explain what is the use. You can use any rectifiers in the series 4001 to 4007. I'm picking up 2 of them from my junk box. I used them already in other projects, but they're in good condition. And then you need 2 diodes. I'm also explaining what is the use of them. Schottky diodes. They're looking pretty similar actually. If you take a look, the shape is actually identical to the standard rectifiers from the 4000 series. Okay? The difference is a standard rectifier 4001 to 4007 is a standard silicon diode, so the dropping voltage, the forward voltage across the diode is 0.7 volts approximately. It may be anything between 0.65 to 0.8 volt. But the Schottky diodes are made using a special technology, and the voltage dropping across is only 0.1 volt or 0.15 at max. Okay, so I'm going to tell you what is the use. And then, what else do you need? Some pins, some headers actually. This is from my jam box I use for Arduino and the Raspberry projects. These are longer pins, and I'm strongly recommending you to have 2 of these. And then standard male headers, short ones like these ones are good enough. So 2 of these and 2 of those, okay? And that's it. This is the list of parts, okay? So I'm gonna leave you till the next week to prepare the parts before rewiring it. And now I'm explaining the use of these parts when we build the project. As you can see here, there are 2 over here. There are 2 standard rectifiers, and over here there are the Schottky diodes. You have to notice that these intelligent digits, if you look in the specifications of them, the pin 7 is the ground. The pin 14, exactly like for a standard integrated circuit, is the pin you energize the logic. The logic inside requires 5 volts, and this is fine. I placed the two Schottky diodes, these ones, only for protection, because in case you accidentally place them like this, you won't burn them out, okay? And this is the reason why I placed here these diodes. But there is a thing about the standard rectifiers, 0.7 volt. When I was making that little project here about recognizing the keyboard keys, the codes for the keyboard keys, I was using a DC to DC converter because of a thing everybody using this kind of intelligent digit knows. They were designed many years ago by Texas Instruments, and the cover, the plastic, the transparent plastic, which is right above the dots, the diodes, is actually an acrylic material. And that acrylic material has a little bad property. It doesn't like the gaps in temperature. So with the time, what's going to happen, like in the heavy-duty application, the industrial heavy-duty applications, after a number of years of use, the acrylic material is cracking. Take a look at this mug. That's made of acrylic, okay? And it has many years of use. And this is the reason why I'm just keeping it to show it to you, because you can see it's cracked everywhere. It doesn't leak yet, but the material inside is cracked everywhere. So when the material is cracking and changing a bit the color, maybe the display won't look that nice anymore. So then you have to find a way to preserve the longevity of these digits. And there are 2 typical ways to do it. One way is to have others in stock and to keep replacing them every 3-4 years, depending how long do they last. Mine are lasting for many years. I never had this problem yet, but I'm not using them in a heavy-duty format. But another thing you can do, I noticed that you can lower the voltage for the pin number 1 of the package, and the pin number 1 is only energizing the LEDs inside. If you lower the voltage, then you are going to lower the consumption also of the LEDs. And I noticed by lowering the voltage like I'm presenting you in this project, I'm going to give you the link again, you can lower it up to maximum or to minimum if you want, 3.75 volts. It cannot be lower than that because the circuit suddenly stops working. So the LEDs, if you bring the voltage anywhere between 4 to 5 volts, you can make their life much longer. And this is why I was using the DC to DC converter to lower the voltage, and I wrote it here on the little yellow label, up to 3.75 volts. For our little project, which is the model, I'm using a much simpler solution. I just put in series with the diodes a standard rectifier, which is going to lower the voltage with 0.7, 0.8 volts. So instead of 5 volts, the LEDs are going to be energized with 4.2, 4.3 volts. And this is just going to be good enough to not have such a big gap in temperature, especially when you keep putting them off and on all the time. And this is happening every time the numbers are changing because you won't have the same dots energized, okay? So that's a very easy and simple solution to prevent this to happen. Now, another little drawback of these kind of intelligent displays is they are not extremely common on the market anymore, because again, they were designed a long time ago, and even if they may be extremely useful, especially when used on a breadboard, because you can save some space for other parts, not very easy to find, but still they can be found. I found them on eBay. And here is another useful information. There is an equivalent to these TIL311, which is called DIS 1417. And they just said that they have a better behavior with the temperatures. So these ones are even better than the TIL311. And they're absolutely pin-to-pin compatible. They look the same. You won't sense any difference when you take a look at them, okay? So for me, it's a very good way to replace the TIL311 by using DIS 1417. So that being said, let's go back to the advantages, because you still have advantages of placing such a module over here. I said one advantage was you save the space for 2 decoders. Another one is that the decoder implemented inside, which is a hexadecimal one, it displays very nicely the letters A, B, C, D, E, F, only uppercase, versus other kind of decoders like the Motorola 14495, which you won't find practically anywhere today. It's over, okay? It's discontinued for many years. But this one is a very nice decoder already inside. So that's another big advantage. And towards myself, you have another big advantage, because I'm giving you not only the pass list, that's very easy, but I'm giving you also the PCB. Here is going to be the component size, so when you plug components, you know exactly how to place them to solder. And when you solder them on the other side, here is the solder size. So I'm going to give you this one as well. And then there is a little trick. In order to be able to use this effectively on a breadboard, you need to pick up wiring out of these modules to connect to your counters. Or like in that situation here for this little project, I'm using shift registers. So counters or shift registers, it won't matter. But from under the module, you have to have some jumpers. And I'm going to give you this one. So when we make effectively wire the project next week, you're going to see exactly where they are, because I'm replicating exactly by putting this darker frame over here. If I'm taking a look to see it, the actual frame here is in red, just to mark the module itself, what is the position of the module on a breadboard. So by placing these wires, these jumpers over here, you have access to use from outside the module to plug the wires on the breadboard to pick up the signals. You only need 4 for each of the digits, because you need the signals, the binary signals, for the inputs of these intelligent displays. And in the top, respectively the button here, the pins on the module are going to connect themselves to the power, okay? So you have several advantages again. One advantage is I'm giving you all the documentation. Another advantage is these ones, they save room on a breadboard because they don't need to put external decoders over here. They look nicer than these ones because they are converted in user-friendly displays, exactly like the 0.56 inches ones. And these are practically the only ones you easily find on the market which are breadboard friendly. And then you can convert these ones to look the same as the others. Okay, so 3 documents are going to be all available starting today. And now you understand what to expect. I'm leaving you 1 week to gather these components, these parts, and then we're going to wire them together. Okay, so thank you very much for today. See you next time to really make it. Bye-bye.